Hi, students. This is the lesson that I was going to teach you this week. I apologize. I taught you my seventh grade lesson. I've just been a little bit out of sorts with my dad's death, so I apologize. Actually, the day that I was supposed to teach you, that's the day that I had to make some really tough decisions. So I'm sorry about that. Here's the lesson. So you got some air pollution lesson, but that was for seventh grade. This is the sixth grade lesson. So it's on waves again. And we're going to go a little deeper with waves. Okay. So if you have Science Source, those are your pages 308 to 313. Okay. And we're going to have fun with waves. So I have two lists of for the activities, and you will see separate videos that I will post for the different activities. So make sure that you watch this first and then watch those. Okay. If you're keeping a notebook, we're all the way up to here. So lots of things that we've done. We've done waves, characteristics of waves last week. This week we're supposed to do transmission of light waves and transmission of light. So we're looking at light waves in particular today. And this is our standard. So understanding that waves now are reflected, absorbed, or transmitted through various materials. And materials mean solids, liquids, or gases. So that is also known as a medium. Okay. So the light waves in particular act differently through those different things, and so do sound waves. So we're going to take a look at how they react. And of course, we're going to look at all the vocabulary concerning a wave. So there are two different types of waves. There are mechanical waves, such as ocean waves and sound waves, like slinkies, moving too. But there's also something called an electromagnetic wave, and that we get from the sun. And we see that in this form of heat and light. And so when we look at these electromagnetic waves all together, we call that the electromagnetic spectrum. And that electromagnetic spectrum is the full range of all the waves that light travels in. And light that we can see is called visible light. Okay? And that's where it is on the electromagnetic spectrum. But visible light only makes up a little portion. And this is where your Roy G. Biv comes in handy, right? Red, orange, yellow, green, blue, indigo, violet. And that is what always comes in that same order because of the wavelengths of those different colors. And I'll get to that a little farther. But notice that there are other waves on the spectrum that you don't see, but we do know they're there because we can detect them with different devices. So, for example, a radio wave we detect with a radio. Microwaves, infrared waves, ultraviolet light, we have different ways that we either use sensing glasses or we use machines to be able to detect these things. And then of course x-rays with an x-ray machine and gamma rays. So this is known as the electromagnetic spectrum. Gamma rays are the shortest wavelengths and radio waves are the longest wavelengths. So remember the vocabulary for wave. The top is called a crest. The bottom is called the trough. Okay, it looks like a trough that a pig eats out of. And this is like the crest of a hill. Okay, same thing. All waves, we talk about these vocabulary words, if they're electromagnetic or mechanical. Okay, so this line right here, remember from last week, is the resting line of a wave. So if it's a flat lake and there's no waves, then the water would be on the resting line. Then if the wind kicks up and you get more waves, then the wave action gets higher. And the higher it goes is called a higher amplitude. So amplitude is how far away from the resting line it is, either high or low. And just remember, as high as the wave is, it's also that far down. Okay, so this is equal to that for one wave. A wavelength is the distance between the crest of one wave to the crest of the next wave, or a trough to the next trough, or any point on a wave to the very next wave, the same point. Okay, those are all known as wavelengths. The frequency is the number of oscillations produced in a certain amount of time. So if you, and this, by the way, is a formula, okay? And so the formula for it is F for frequency. The number of waves is right here. So number 1 is there for the number of waves. But if there were 2 waves, then you would count 2 in how much time. So if you're counting 1 wave, how long did it take? You measure the time here and then you divide it. And that tells you the frequency of the waves, how many waves you're going to get in a certain amount of time. Okay, that's always measured in something called hertz. So that's how we measure it. And time is the time it complete one cycle, and we measure it in seconds. Wave speed is a little different formula, but they're very similar. That one, the last one, frequency, let me go back to that one, is we're measuring how many waves are coming at us in a certain amount of time. This one, wave speed, we're measuring 1 wave and how far it travels, okay? So this one is a different formula. This one is the distance over the time, and that's called speed. And anytime you measure the speed of anything, it's always the same. Speed equals distance divided by time. So if you were to measure a car, you'd measure how far it went and how long it took. If you were measuring a runner, you'd measure how far he ran and the time it took. Or if you want to measure a wave, you'd measure how far it traveled and how long it took to travel that far. Okay, so all of those are how you calculate the speed. So let's get to something new this week. So for a new thing this week, or new vocabulary, I want you to learn the law of reflection. That's what this is called. And it refers to light waves, but it also can refer to a sound wave. When a wave comes in from the sun, let's say, and it hits a flat surface like a mirror, okay, not necessarily a mirror, but a mirror is a good example because you can see a mirror in the light. When it comes in and hits a flat surface, it reflects the same exact way that it comes in. We call that an incident ray, the ray that comes in, and a reflection ray, the ray that goes out. So that's the reflected ray, that's the incident ray. And the angles are equal on those rays. So if you were to draw a straight line right here, perpendicular line to the flat surface, this angle would be equal to this angle. So the angle of incidence is always equal to the angle of reflection. And again, that is on a flat surface, okay? So knowing that, next time you're in a mirror, look straight ahead and you'll notice that your law of reflection is equal to the law of incidence. In other words, you're looking straight on, so you're going to get a straight on image. But if you just slide over a little bit and you look from an angle, you're now going to see into the mirror in an angle, and you're going to get a much wider angle of reflection. So you're going to see a lot more of the background behind you. Check it out next time. Look in a mirror and see that. So your reflected ray is going to be equal to your incident ray. If you widen your ray, then you're going to widen your incident ray and your reflected ray. Okay? Now, those were all on a flat surface. Let's talk about a diffuse surface. So diffuse or rough surface diffuses light. So what does that mean? Well, this flat one where the incident ray comes in and it hits and it reflects perfectly, that's called a specular reflection. Specular means it hits a flat surface. Okay? For example, a parking lot. All right? Or a mirror. Good example. But a diffuse reflection is when it hits a rough surface and the light comes in and then it has to go bouncing off of lots of little things and it goes in lots of directions. So that is why when you go to the beach and you're in the parking lot, you need sunglasses. Let's say if it's a bright sunny day and the light is hitting off the parking lot and it's coming into your eyes, but your eyes kind of adjust. But then when you go out to the beach, your eyes all of a sudden get like it's a lot brighter. And then the reason why it's a lot brighter and you need sunglasses for sure at the beach is because you're getting the light coming in and then it's hitting your eye lots of different angles because it's hitting off the beach sand. And the beach sand is making the light bounce in lots of different directions. That's called a diffuse reflection. Okay, so specular reflection is when it hits and bounces. Diffuse is when it hits and goes in lots of different ways. Now, we can use this to our advantage because, for example, if you've ever been in a house of mirrors at a carnival, when you go in a house of mirrors, you'll see that your reflection changes and or you can't see yourself sometimes. It's the way that they angle the mirrors because they know about specular reflection. Okay, sometimes they curve the mirrors and they diffuse the reflection. So it's kind of interesting how they work those. All right, so let's look at how light behaves. So all light travels in a straight line. That's true. It does. But it can bend or get reflected or get diffused when it goes through a different medium. Okay? So let's just talk about solids for one thing. When it goes through a solid that is clear, like a glass of water, okay? When it goes through the top of this glass, there's no water there, so the light goes perfectly through it, and you can see right through it. But this glass has little images, you see that, of circles. And these circles are diffusing the light. So when you look through the circles, you can kind of see the image, but you can't because it's being bent or diffused, okay? When you look through the water definitely diffuses the light and it makes it blurry. That's because the light is bending and it's going in lots of different directions, being diffused and slowed down. When light travels through gas, it goes faster than when it travels through water. Water slows it up a lot. When it travels through a solid, it goes through much quicker, okay? Only if the solid, of course, is transparent. That means see-through. Translucent means that some of the light is diffused. For example, these blocks. Have you ever seen these blocks in a bathroom? Most people, when they're going to use these blocks, they put them in a bathroom. Why? Well, you can kind of see what's behind there, but you can't. Okay? It diffuses the light so much that it allows sunlight in, but you can't tell what's happening behind the blocks. Okay? You can kind of tell that this is a tree, but you really can't see the tree perfectly. That's what translucent means. It means that the light is being diffused a little bit so you can kind of see an image, but you can't really tell exactly. It's not a clear image. And then opaque means that the light doesn't pass through at all, like a brick wall. Good example of opaque. Okay, it stops the light from traveling through, so you can't see. All right, so let's talk about this term, refraction. Refraction is when light actually makes something appear to bend or change. And the way that it does that is because light is coming through an object, and if it's a water, like a liquid, it slows it down and it diffuses it a little bit. When it goes through a solid, it goes through quickly. When it goes through a gas, it goes through slowly, but you can still kind of see it. So let's take a look at this. This glass right here, if I put a pencil in it, okay, that pencil appears to be broken. You see at the very, very top, right there, that pencil appears to be broken. And the reason that's happening is because the light is traveling faster through the top, through the gas and the solid, and slower through the liquid. So it makes it appear bent. It's not bent, right? It's a solid pencil, but it appears bent because of that light being refracted. And so refraction is something that I'm going to show you on a separate video. So there are a couple of videos that I posted, and one of them is on refraction. And another one is on the angle of incidence and the angle of reflection. And then the third one is kind of on some fun stuff. You're going to see one on an ice cream cone that I drew, and I'm going to ask you how that happened. And then the fourth one is kind of a fun one that doesn't really have anything to do with light, but it was kind of goes along with all this. So I did it and I threw it in there for you as an extra. Okay. So we'll talk about those in class at the beginning class this week. And don't forget, we're going to have an extended class this week. I'm going to add more to the class this week. So we'll definitely play a game. All right. So law of reflection is when the light bounces off of a flat object, and it's called specular reflection. So it comes in, it bounces, and it goes out. Okay. That law says that the angle it comes in is equal to the angle it goes out. Those two rays are equal. Reflection can be either specular or diffuse. That means it goes in lots of different ways because it's hitting something rough and the light is being reflected in lots of angles. Good example is beach sand does that. And then when light passes from one medium to another, like through water, it can be refracted. So please watch the other videos that I post so that you can understand a little bit more about refraction and about the angle of incidence and the angle of reflection. Okay? And I will see you guys this week, and I will ask you the answers to the two that I show you in the videos that I ask you how I did it. Okay? All right. Thank you guys so much for putting up with me. I'll see you this week. Bye.